here is the rest of the section on integration by partial fractions. So hopefully by now you've already watched the video that explains the algebraic nature of it, but now I want to go through and actually get through some full questions that are the calculus piece of all of it. So some things to keep in mind. When you're using this technique, it's definitely not one of the most common techniques. You're going to do a lot more with U sub and things from Calc 1. But what you're looking for is you're looking for something that's rational, has a numerator and denominator, and the denominator can't be factored. You're also trying other things first. You're making sure it's not a U sub. You're making sure it's not something where you can do an inverse trig. So you've got this denominator, so your first step is to factor it. When you write your factors, it does not matter the order that you write them in. It will change, like if you put them in a different order than the person next to you, then your A and B would be flip-flopped, but it's not going to change your final answer. So we're going to break it down into A over x minus 2 and B over x minus 3. So we're going to clear fractions, which means multiply by x minus 2, x minus 3. So when I do that, on this side, I'm just going to have a 1. I'm always going to be left with the original numerator. On this side, my A is going to be left with the x minus 3 because the x minus 2's will cancel. And my B will be left with my x minus 2. I'm going to choose x's. I always call it the picking x's technique, which is not very technical, but it makes sense to me. I'm going to choose x's that are going to make things cancel. So I'm going to let x be 3 and x be 2. Doesn't matter which one you do first. When I let x be 3, I'm going to get 1 on the left side. The a term is gone, and I'm actually just going to get b on the right side. So b is 1. When I let x be 1, I'm going to get 1 equals negative a. So a is negative 1. So what I have is I have negative 1 over x minus 2, and I have positive 1 over x minus 3. And that's what I'm integrating. And I'm going to integrate them as two separate terms because that's what they are. That's what partial fraction does, is it takes something that is big and breaks it down into smaller pieces that are manageable. Both of these are going to be natural log because your u is your denominator and the derivative is just 1 or dx. Same thing on the second one. You don't even have to write that. Whatever your coefficient is, it's going to come out front. So I'm going to have a negative natural log of x minus 2. And I'm going to have a positive natural log of x minus 3. So a quick statement about answers. Sometimes on the AP test, this will be the answer. Other times, they are going to use logarithm properties to take these multiple logarithms, especially when you have 2 or 3 of them, and condense it into one. Since this one is negative, if you think about your logarithm properties, when you subtract logarithms, it's the same as dividing. So you can actually see this answer on AP test written as the natural log of x minus 3, because that's the positive one, divided by x minus 2. I am not saying you have to do that on a test with me, but I am saying look for that in a multiple choice question because the AP writers love to make you condense with logarithms, and so you'll see that often show up as an answer. Here's another one. Same thing. We're going to factor. As you're going through these, if you want to pause this video, try it on your own, then listen to my answer. Sometimes it's a lot more active and not as passive. So I'm going to have a over x minus 3 and b over x plus 1. Probably want to get in the habit of watching me do a full one, kind of going through, jotting it down, and then having the ones after that you're trying on your own, pausing the video, and then kind of listening to me run through it. So I have, when I clear fractions, 5x minus 3 equals a times x plus 1 and b times x minus 3. I'm going to let x be negative 1 and positive 3. I always take up so much space with these. When I put negative 1 into the left side, I get negative 5 minus 3 is negative 8. The a term will cancel. When I put negative 1 into this term, I get negative 4b. So that means b is 2. When I put 3 in, I get 15 minus 3 is 12. And then 4a, so a is 3. So you're going to see it written as 3 over x minus 3 and 2 over x plus 1. Both of these will be natural logs with no adjustment. The 3 and the 2 will come in front. You can write your du over u if you want, or you can go straight to your answer. 3 natural log of x minus 3 plus 2 natural log of x plus 1. I am perfectly fine with that answer, but we know the AP likes to condense. So one thing you can do is you can make this 3 a power. You can make this 2 a power. You can also combine it with the addition. It gets squished together with multiplication. So you could see an answer that's written all the way like this. So x minus 3 cubed, x plus 1 squared plus c. And that whole thing is being multiplied because it's been condensed with logarithm properties. Here's one that's about as bad as you can get as far as the length of problem. I haven't seen a lot on the AP test that take it to this extreme, but if you see it, I want to make sure you can do it. The nice thing about this one is it's been pre-factored. It's already done. I don't know if pre-factor is a word, but get the idea. But you have 3 of them. So you have a over x plus 1, b over x, or x minus 1, excuse me, b over x minus 2, c over x minus 3. When you clear fractions, you're going to be left with 6x squared minus 17x plus 25. With your a term, you're going to be left with the x minus 2 and the x minus 3. With the b term, you're going to be left with the x minus 1 and the x minus 3. I'm going to run out of room. And with the c term, you're going to be left with the x minus 1 and the x minus 2. I actually have to choose 3 x's because I need to find 3 unknowns. But the nice thing is all of them are easy to establish what you need to choose. Probably the toughest part might be the mental math. Hopefully I have a calculator not too far away from me. So when I put 1 in, I get 6 minus 17. 6 minus 17 is negative 11 plus 25. I get 14. I really hope I'm not doing mental math wrong. When I put 1 into the a term, I get negative 1. So I'll have a. I have negative 1 and negative 2 when I put 1 in. And that gives me 2a equals 14, so a is 7. I don't have to put it into the b term or the c term because it's going to cancel. Then when I put 2 in, so now I don't want to mess up mid-video, so 6 times 2 squared, so 6 times 4, minus 17 times 2, plus 25, you get 15. 2 is going to cancel the a term, it's going to cancel the c term. We are going to have a b term, so we're going to have b. When I put 2 in, I get 1 times negative 1, so that means b must equal negative 15. And now when I put 3 in, so 6 times 3 squared minus 17 times 3 plus 25, I get 28. 3 will cancel the a term, it'll cancel the b term, so we're going to go all the way to the c term. When I put 3 in, I get 2 and 1, so I get b to be 14, c, excuse me, to be 14. So my parts, when I do my decomposition, is one of them is going to be 7 over x minus 1. One of them is going to be minus 15 over x minus 2. And one of them is going to be 14 over x minus 3. Now, the nice thing, again, they're all natural logs. They don't have any adjustment. And I keep saying that. I want to make sure you know why. If I let u be the bottom of any of these, x minus 1, x minus 2, x minus 3, the derivative of them is just 1. So that's what I mean by no adjustment. You will run into ones where the denominator is like 2x plus 1 and where you have an adjustment. So watch for that. They're all natural logs. The coefficients just come out front. So I have 7 natural log of x minus 1, minus 15 natural log of x minus 2, plus 14 natural log of x minus 3, plus c, with a very, very long answer. I want to show you, I don't know if I'm going to go through do both of these, but I do want to do the first one just because it has that adjustment piece that I've talked about. So with this first one, this factors 2x plus 3, 2x minus 3. So when I break it down, I get a over 2x plus 3. I get b over 2x minus 3. When I pick my x's, I'm going to pick negative 3 halves and positive 3 halves. You're always going to get 1 on the left side since there's no variable there. My a is going to go with 2x minus 3. My b is going to go with 2x plus 3 when I clear fractions. When I put negative 3 halves in, that's going to cancel the b term, so I'm going to go to the a term. So if I put in 2 times negative 3 halves and then minus 3, I get negative 6, so I get 1 equals a times negative 6, so a is negative 1/6. And then I'm going to do the same thing to find b. I'm going to put 3 halves in this time, so I get 1 equals, when I put 3 halves in, I get 6b, so b equals positive 1/6. So here's where I want to watch the end. So I'm integrating negative 1/6 over 2x plus 3, and I'm integrating positive 1/6 over 2x minus 3. Here's the easy thing to miss. When you're doing a u sub with this, and I know a lot of them we're doing in our head, if you let u be 2x plus 3 or 2x minus 3, du is 2. So there will be a 1/2 adjustment. There will also be a 1/6 or a negative 1/6 out front. So you're actually going to end up with a negative 1/12 natural log of 2x plus 3 and a positive 1/12 natural log of 2x minus 3 plus c, which I'm just going to say because I don't have room to write. So I wanted you to see one like that with adjustments because I feel like that's what they expect that you're going to miss. The last one's on here if you want to kind of try it on your own. It is a really simple one, going back to very, very basic factors and no adjustments to work with. But this gives you an idea of kind of what to expect with all the different questions from this topic.